Nightmare mode detected.
Whoa, another nightmare, huh?
Yeah.
Don't worry, we are all good here. Our space journey is going to be fine. Remember, we have a lot ahead of us. Tigerbot, could you please share the itinerary, please?
Itinerary loading.
All right, here we go. So, we are going to be exploring asteroids, some of which are your source of anxiety. Then we'll also be checking out satellites. Oh, don't forget, we'll be heading to the moon too.
I know. Honestly, I'm really looking forward to better understanding how we can protect our Earth.
Me too.
All right, let's go.
Lei, do you remember what happened back in 2013? No one saw that asteroid coming until it was already hurtling through Earth's atmosphere.
Yeah, that was a close call. Luckily, it was minor, and the damage was limited.
But no need to panic. Statistically, you're more than 10 times more likely to win the lottery. Twice. International scientists are closely monitoring what's happening beyond the planet's atmosphere in real time, while using high-tech instruments and cutting-edge analysis.
Let's check in with Sun Ye, who is now in one of China's main observatories in Jiangsu province.
I am right beside the China Near-Earth Object Telescope, also one of the most important night watchers in the International Asteroid Warning Network. Now, for this telescope, its mandate, ever since it's born in 2006, is to find and track asteroids, also to warn their dangers to the globe with its wide and far field of vision.
That system can go global, bringing together partners and industry leaders. Oh, I know just the right person to chat with about this, Dr. Finchtinger from the IEF.
Important here is efficient monitoring of near-Earth objects, certainly early detection, and then a globally coordinated mitigation strategy. On the other hand, asteroids and near-Earth objects also provide a unique opportunity for scientific research, and they also will contribute to sustainability to life on Earth by providing sources of off-Earth resources.
Lei, look at these. They're the China-Brazil Earth Resources satellites. You know, the two countries have been collaborating on these satellites since the 1980s.
Wow.
And all the data they gather is crucial for so many fields.
They've also been instrumental in protecting the Amazon rainforest by monitoring deforestation.
Wow, I think I've got the perfect person to tell us more about this.
Today, more than 1 million images were distributed for many countries around the world. That was the possibility to promote the analysis of images for all countries around the world. It was a really great contribution of Brazil and China for the world.
Yilin, look here, there's another one. It's the first astronomical satellite jointly developed by China and France. It's hunting gamma-ray bursts right now, and it helps scientists decode the origin of the universe.
There's more. Shifting gears to the oceans with the China-France Oceanography Satellite. Blasted off in 2018, this satellite helps us understand ocean dynamics. So much crucial data delivered on climate change, storms, and sea safety. Together, who knows what we'll uncover next?
This one here, Yilin, the Meteosat 2, it's a project by China and Egypt.
Through our strategic partnership with China, we managed to establish a state-of-the-art assembly integration testing facility, which is considered to be the largest in Africa and the Middle East. In addition to the launching of Meteosat 2. Actually, this was our opportunity to learn and to have capacity building in the field of assembly integration testing and operating satellites.
All right, just keep track of things. Brazil, France, and Egypt, all coming together with China in space.
And there's plenty of room for more countries to join. I think Ms. Artola Mani can tell us more about that.
Knowing that brilliant minds exist in all countries. There are researchers, there are universities, very sophisticated. The brains are there. The capacity, the infrastructure may not be there, but the intelligence and the capability is there. And I think developing countries, the spacefaring nations, realize that they have a lot to gain, not just to foster greater international collaboration, but also to benefit from different perspectives and different insights from these countries.
Yilin, we're almost there, just approaching the far side of the moon now. I think a lot of us still remember the Chang'e 6 mission that took place here.
Chang'e 6 also carried 4 international payloads from ESA, France, Italy, and Pakistan.
Chang'e 6 has demonstrated beyond any reasonable doubt that a reflector of that small dimensions, size, and mass can be observed efficiently with a percent success rate about 30%. We have delivered another microreflector. This was a reflector which was in China already since the past. This has been qualified by the Chinese partners, and then we'll proceed with a similar scheme, an old reflector already delivered in China being qualified by them for Chang'e 8.
CNSA has selected Pakistan's rover for Chang'e 8. And now, currently, the preliminary design process of the rover is underway. Pakistan is now part of the ILRS, and in ILRS, there are so many projects there, and we look forward to those projects.
Awesome! Okay, Lei, I think we can now head to our final stop, the lunar South Pole.
Let's go!
Lei, you know what's really cool about the South Pole? There are these areas called permanently shadowed regions that never see the light of day. And it's precisely in those parts that there may be water ice.
It's a major objective of the Chang'e 7 mission. It will search for water ice and carry out a series of scientific explorations to deepen the understanding of the lunar South Pole.
Looks like this place will really be in the limelight in the years to come.
And don't forget, the Chang'e 8 probe will carry out experiments on lunar resource utilization in its vicinity, and along with the Chang'e 7, they will constitute the basic model of the Lunar Research Station.
Lei, I know the person to learn a lot more about this endeavor. China's Lunar Exploration Program Chief Designer, Mr. Wu Weiren.
我们希望能够在探月4期建设的基础上，能够由中国发起，多个国家参与这么一个国际大科研工程。目前进展还是很顺利的。这个科研站呢，能够能源自动供给，是吧？通信能够就地实现，以月球南极为中心，然后由月面和月球轨道这么组成，可以向更远的地方辐射。按照我们目前的建议啊，或者我们的设想，我们希望能够实现50个国家，500个国际科研机构或者组织，再就是能够有5000名国际科学家一起共同参与，我们共同分享我们的探月的成果。当然，最终我认为我们月球科研的建设啊，要为将来奔向火星服务。
Think of all the countries and experts coming together.
I think this is my favorite part, people working together for common advancements.
All right, how shall we move forward?
Agreed, our journey doesn't end here, right, Taikovat?
Oh yes, I'm ready.
Initiating blast off. Destination: infinity
And beyond.